Welcome to EGBT channel. Myself, Ravi Kumar. Please subscribe our channel and share to your friends. In this video, I am discussing about the how to calculate the AC circuit parameters. That is, how to find out impedance value or admittance value, current, all powers value, and also power factor value in the given single phase AC circuit problems. This type of problems are very most important in university examinations. Okay, this is the example problem. In this problem, a coil of resistance 10 ohms and inductance of zero point 0.1 Henry is connected in series with a capacitor of capacitance 150 microfarad across 200 volts 50 hertz supply. Calculate impedance, current, power and power factor of the AC circuit. First of all, according to the given values, you can draw the single phase AC circuit. In the given problem, R value and L value and C values are given. Hence, it is connected to single phase AC supply. This is the circuit diagram based on the given data. The voltage value is given, that is 200 volts with frequency 50 hertz. R value is given, that is 10 ohms. L value is given 0. 0.1 Henry. Capacitance is given 150 microfarad. The value of micro is 10 power minus 6. That is, the capacitance value is given 150 into 10 power minus 6 farad. Hence, you can assume the current passing through the circuit is I. This is the given RLC circuit based on the given values. In some of the problems, only R value, L value are given. Then draw the series RL circuit. Or R value, C values are given. Then draw the series RC circuit. Or combination of R, L, C. Like this problem. Then you can draw the series RLC circuit along with the voltage source. Can see the given circuit values. Based on these values, you have to find out the required values here. Then after drawing the circuit diagram based on the given values, then the first value you have to find out is impedance. What is the total impedance of the given AC circuit? The impedance should be denoted by capital Z. In the given circuit, what are the elements are given? R value, L value and C value. Hence, we know the formula of impedance is R plus Jx. R nothing but resistance and X nothing but reactive component. In this problem, we have two components, inductance and capacitance. Then, what is the reactive components of inductance? XL. And what is the reactive components of capacitance? XC. Then, here the XC have minus, that is minus XC. That is, the value of XC is nothing but 1 by j omega c. Then you should equalize is minus j by omega c. That's why this minus appear for capacitance. Hence, write down the XL minus XC. Hence, R plus, what is the value of XL? That is omega into L. What is the value of XC? That is 1 by omega c. Again, from that, What is the value of omega? We know the formula is 2 pi f. Then into L minus omega value is 2 pi f into C. Then already we know what are the given values in the problem. That is R value is given 10 ohms, L value is given zero point 0.1 Henry, C value is given 150 into 10 power minus 6 Farad, and frequency is given. Frequency value is 50 Hz. In this problem, the value of frequency is 50 Hz. Total voltage is 200 volts. That values are given in this problem. All values are we know. Then find out what is the total impedance of the given circuit. What is the R value? 10 plus J. You can replace the values of R, L, C in the impedance equation. That is J into 2 pi F. F means 50 into L value is zero point 0.1 minus 1 by omega c. That is 2 pi Fc. 2 pi into F means 50 into C value is 150 into 10 power minus 6. Okay, by using calculator, you can simplify the equation, total equation. The value is, you have to find out is 10 plus J 31.5 minus J 21.22 for total value. Hence, Z is impedance value is 10 plus J 10.194 ohms. So the units of impedance is ohms. So this is the total impedance value of the given AC circuit. But here in this form of rectangular form, you can convert rectangular form into polar form. Hence, the value is 14.279 magnitude at an angle 45.55 degrees ohms. So this is the rectangular form of the given impedance value. If you know the impedance value, it is easy to find out total admittance of the given circuit. Then admittance, it is denoted by capital Y. The admittance is reciprocal of the impedance value, that is 1 by Z. Already we know the value of Z value is 14.279 at an angle 45.55. Then 1 by 14.279 value is nothing but 0.07. Then plus 45 is moving to numerator. Hence, positive angle changes to negative value. Negative value changes to positive value when the angle moves towards the numerator. Then minus 45.55 degrees. The units of impedance is moles. Okay, like that, we have to calculate impedance value as well as impedance value for the given AC circuit problems. After finding total impedance value, then according to Ohm's law, what is the Ohm's law in case of AC circuits? V equal to IZ. That is, we know the Ohm's law. From that, we know the total voltage value is given in this problem. We calculate total impedance value Z, then find out the total current which is passing through the series RLC circuit. V value is 200 and Z value is 14.279 at an angle 45.55. Hence, this value is nothing but 14 at an angle minus 45.55. You can simplify the equation. Okay, like that, you can find out the total current in the given AC circuit. Okay, after finding AC circuit, you can find out the other parameter, that is power factor of the given AC circuit. What is the formula for power factor? That is cos phi. Here, what is the value of phi here? That means what is the angle you have to calculate it in the impedance value. That is, in this problem, the angle of impedance is minus 45.55. So this value is, the angle of impedance is nothing but the phase angle of the circuit. Then you have to calculate the power factor by applying cos of angle of the impedance. That is cos of 45.55 degrees. That value is zero point 0.7. The power factor is positive value, then it is the lagging power factor. If you get the power factor is minus, for example, minus zero point 0.7 will obtain, then that is called the leading power factor. If after calculation the value of the power factor is positive, that is called the lagging power factor. The value of power factor is negative, that is called the leading power factor. Then after finding power factor value, hence we have to find out the what is the power's value. We know the first power is active power, which is denoted by capital P. What is the formula for active power? That is VI cos phi. We know the value of V 200 into what is the value of I, that is magnitude 14 into cos of angle. We know that is zero point 0.7, or we have write down the cos of 45.55. Hence, we can find out the active power is 1.9 kilowatts. This is the value. You can simplify. Hence, the second power is, that is reactive power, which is denoted by Q. The formula is VI sin phi. We know the value of V is 2, the value of I is 14, hence the value of sine, that is sine of 45.55 degrees. You can simplify, the value is same, that is 1.99 kVAR. The units of reactive power is kVAR, kilo volt ampere reactive. Hence, after finding the second power, reactive power, then we have to find out the third power, that is apparent power, that is denoted by S. The formula is V into I. That is, the value of voltage is V, the value of current is 14. Then we have to obtain 2800 volt ampere. Write down in the form of kilo 2.8 kVA. This is the value of apparent power. Like that, in the given single phase AC problems, first of all, you can find out the, after drawing series circuit, given series circuit with the help of the given problems, R value, L value, C value, then draw the circuit. After that, find out the total impedance value of the single phase AC circuit, that is Z. Then by using the formulas, R minus R plus JX, X nothing but reactive components. The reactive component of inductance is XL and the reactive component of capacitance is XC. Then XL minus XC. Replace all values by using the formulas and calculate the impedance, and we have to calculate impedance y equal to 1 by z. Then by using Ohm's law, we have to find out the total current passing through the circuit. Then here in the calculation of impedance, the angle which is obtained, you must convert the impedance value you have to calculate in the form of polar form. That is, rectangular must be changed into polar form also in order to find out the phase angle phi of the circuit. Then you can find out by using phi cos phi, that is the power factor of the circuit. Hence find out all the powers, active, reactive, and apparent powers. Like that, you can find out the any all powers or impedance value in the single phase AC circuit problem. For example, you have to consider another example problem. You can find out there is a if the given problems are R value, L values are given, then how to find out the equations of the elements. That is what is the equation of the voltage and what is the equation of the current. For example, consider the circuit consists of only resistance. There is no any reactive components. That is single phase AC circuit consists of resistance element only. The value of resistance is given 10 ohms. Consider passing current is I. Total voltage is 230 volts, 50 hertz. Frequency F is given 50 hertz. Then find out the current value, powers value, and equations also in the given circuit. Okay, here the simple circuit is only consists of resistance. Then what happened? Total impedance value is Z equal to R. There is no reactive components. That's why there is no imaginary part. 10 plus J0. The total impedance value in this AC circuit is 10 plus J0. From that, we have to find out what is the total current passing through the circuit. The given voltage value is 230 by Z value is 10. Then the current passing through the circuit is 23 amperes. Hence, current we know the current value and voltage value. This circuit consists of only resistance. Hence, we have to find out the active power. There is no reactive power in this circuit. Why? Because there is no reactive components, that is inductance and capacitance. That's why in the circuit we have to calculate only active power. That's why that is only V into I in case of resistance. That's why V value is 230, I value is 23. Then the total power is 5290. That is 5290 watts. That is the total power which is consumed by the resistance. Okay, here the power factor angle, that is phi is 0 degrees. So there is no any reactive components. That's why angle phi is 0. Hence, for resistive circuit, what is the power factor value? That is cos phi equal to 1. That is cos 0 degrees equal to 1. That is the power factor value for resistive circuit is always unity. Then we can find out the equations of the voltage. We know that is V equal to what is the sine equation? Vm sine omega t. This is the equations of the voltage, and also equations of the current also same equation, that is I equal to Im sine omega t. Vm is the maximum value, but we know the value of RMS value. From RMS value, what is the relation between RMS value and maximum value? That is maximum value equal to root 2 into RMS. Then root 2, the given values are RMS values, that is 230 into root 2. sine. What is the omega t value? Omega value 2 pi f into t. That is root 2 into 230 value is 325.27 sine 2 pi f. F value is given 50 hertz. Then omega value is 314.314.16 into t. So this is the equation of the voltage. Like this, you can find out the omega value and maximum value. Same, you have to find out current equation also. I am nothing but root 2 into RMS value is 23. Same, sine 2 pi into f nothing but 50. Hence, the values are root 2 into 23 is nothing but 32.53 sine 314.16 into t. This is the equation of the current. Okay, that is in the given circuit only consists of R, or only consists of L, or only consists of C. Okay, that is only one element is given in the given circuit. From that, you can find out the total impedance value and current value. Okay, from that, the values of the given values are finding values are RMS values, that is the V and I. From that, we have to find out the maximum values Vm, Im. Then you can replace the values in the sinusoidal equation. What is the sine equation? Vm sin omega t or Im sin omega t. Then replace the values of maximum value and the value of omega also. Omega nothing but 2 pi f. We know that. F value is given. What is the standard value for frequency? 50 hertz. Okay, from that, replace all values. Then find out the required voltage and current equations in the given circuit. Okay, these are the examples. In this way, you can find out the impedance value and current values as well as power values also in the given single phase AC circuit. Please subscribe our channel and share to your friends.